Speed up. So I was slowing down, boom. Now, oh wait, oh, that isn't the ooh moment. We're leading up to a big ooh moment. Now, let's play name that shape. Triangle. Well done. Bonus question.
Oh,
How do you find the area of a triangle?
based on how the women see.
1/2 base times height.
Oh, because there's it's not a square.
But could that, okay, just because it's not a square doesn't mean that it's a triangle. Okay? But let's go with the fact that it is a triangle.
Yeah.
Okay. Now, big picture. Big picture. Let's say that it went 3 meters away from me. How would 3 meters, if it went 3 meters away from me, how would that be manifested on this graph?
The X intersection.
That would be the area. Oh, Connor A. That would be the area. So if I went 3 meters away, that would represent the area, right? So that would be 3 meters. True? Now, let's say for the sake of argument that took 2 seconds. I timed it. From the time that I let go of it until the time that it got as far away from me as it's going to go, that was 2 seconds. What would the 2 seconds represent on that triangle? The base. The base would be 2 seconds. Could I find the height?
Yeah.
Oh, height would represent what? Somebody said it. The initial velocity. So even though I don't know what the initial velocity is, if I know this is a triangle, which it is, and I know the area of a triangle is 1/2 base times height, so if I were to solve for height, I'd take 2a over b and get my height. Good with this.
For sure.
So I'd take 2 times 3 meters, divide that by 2 seconds, and I would get what?
3 meters.
Which would represent the initial velocity of the cart that I pushed to bed. What was that? Ooh, ah. That's a new ah moment, by the way. Okay. That went well beyond ooh. That was ooh ah. Okay? Now, but why couldn't I just take the 3 meters and divide that by 2 seconds and go with 1.5 meters per second? Because what's it doing? Is it moving at a constant velocity? No. Now, if you were to find that area, what would that area get you?
Should be the same,
But
right?
negative 3 meters. Why?
Because below.
Below zero. Also, here's the deal. When you calculate displacement, that's position final minus position initial, P minus P naught. On the way out, what was my initial position?
Zero.
What was my final position?
Zero.
No. On the way out.
3.
Final position was 3. If I take 3 minus 0, check my math, I get 3 meters. Now, on the return trip, what's my initial position?
3.
What's my final position?
0.
Then I'd take 0 minus 3, and I'd get negative 3 meters, which is that area.
Yeah.
Okay? Makes sense. If I were to add those 2 areas together, what would I get?
0.
Why?
Because you kind of.
3 minus 3 is 0.
3 minus 3 is 0, and my initial position is the same as my overall displacement is going to be 0. Ooh. What was the total distance traveled?
6.
Distance traveled was 6. What's my overall displacement though?
0.
So you can have no displacement but travel 6 meters.
Oh. That's crazy.
Ah.
Working on that. Okay, stop that camera for a second.